AP Stats Unit 2 Test Number 1. Which of the following statements about a normal distribution is false? You are given 5 statements that we're going to go through one by one. The first statement is that the mean is equal to the median. We know in a normal distribution that the mean is the balance point and the median has 50% of the values above and 50% of the values below. So it makes sense that if 50% of the values are to the left of this line and 50% of the values are to the right, that both the mean and the median would be right in the center. With a 50-50 balance and a 50-50 split, that means that the mean and the median are both equal to each other. Moving on to part B, the statement says Q1 is the same distance from the mean as Q3 is from the mean. As we said previously, the median has 50% of the values above and 50% of the values below. Also note that in question A, we discovered that the mean is equal to the median. So if this is 50% of the values and this is 50% of the values, we know that Q1 has 25% of the values below and Q3 has 75% of the values below and 25% of the values above. So the distance from 25 to 50 is 25 units, and the distance from 50 to 75 is also 25 units. So then we now know that Q1 is the same distance from the mean as Q3 is from the mean, because 25 units equals 25 units on both sides. Part C states the area below z equals -2 is approximately 0.02. To find the area, you'll need to use your calculator. First, you're going to hit second distribution, then go down to normal CDF. You're going to plug -10 into your lower and -2 into your upper. Then when you hit paste, you should get an answer around 0.023, which then can be rounded to 0.02. This means that the area below z equals -2 is approximately 0.02 is correct. Part D states that the area between z equals -3 and z equals 3 is 3 times as big as the area between z equals -1 and z equals 1. To start off, we're going to find the area between -1 and 1, which is this section right here. And just as in Part C, you're going to use your calculator. So you're going to go to second distribution, normal CDF, and you're going to plug -1 into the lower and 1 into the upper. And then you should get an area of around 0.68. Now we can do the same thing to find the area between -3 and +3, which is this section right here. So you're again going to go to second distribution, normal CDF, but now you're going to plug -3 into the lower and 3 into the upper. You should get an area of around 0.997. Now if we look at the area between -1 and 1, we can see that it is not at 3 times as big as the area between -3 and 3. So we can say that this statement is false. Even though we said part D was incorrect, we want to be absolutely sure of our answer. So part E says a value at z equals -3 will be considered an outlier using the 1.5 times IQR rule. So if we know that Q1 has a z-score of about -2/3 and Q3 has a z-score of about 2/3, we can approximate that Q1 is about right here and Q3 is about right here. So if this was the case, Q1 would be 10 and Q3 would be 14. So if Q3 equals 14 and Q1 equals 10, 14 minus 10 equals 4, so the IQR is equal to 4. When we multiply 4 by 1.5, we get 6. So since we're looking for the z-score of -3, we have to do Q1, which is 10, minus 6, which equals 4. So that would mean 3, which corresponds to a z-score of -3, would be an outlier. So we know that part E is correct. Now we can conclude that of the following statements about a normal distribution, the area between z equals negative 3 and z equals 3 is 3 times as big as the area between z equals negative 1 and z equals 1 is indeed false. And that's the end of question number 1 on the Unit 2 AP Stats test.